Right, so, yeah, like we're gonna do neural nets for like an hour in JavaScript, and yeah, the overall idea was this thing where we want to implement an app that, do people still say app? Implement an app that will where like a human can program a small multi-layer perceptron. And we're looking at it from the interpretation of like, I mean, like basically what an MLP is doing is, like moving the input points around in like a high dimensional geometry. In our case, binary geometry. And so basically what it has to do, if it's doing binary classification, it has to move all of the like input points that receive +1, has to like in some sense move them close together. That's not strictly true. Like it actually just has to make them linearly separable from but if they are very close together, then they are linearly separable. So yeah, so it's kind of like moving them close together in like a Hamming distance sense, because like everything we're doing is binary. It's actually like a harder task, I guess, and but it's more interpretable because it's you you can't really tell like if, I don't know, it's hard to tell when like points are linearly separable. That's actually NP hard. So anyway, yeah, so this is how the app currently is working, and what we are I don't know, let's say I think this is maybe 4 dimensions. Nah, it's 5 dimensions. So we have 32 rows. Each of these little. This is a Hamming distance matrix, and it has like, so like each, yeah, there's 32 rows. So an individual row is one of the 5-dimensional binary vectors, and each column is a 5-dimensional binary vector. And so what we're visualizing is going through the neural net. This is a, like, I don't know, like a 20-layer neural net or something. Also, like, I've implemented Zoom, obviously. When I say I mean like AI has implemented it. But I have not yet implemented mouse panning, so we can't really pan. But anyway, this is the first layer. Also, I need to I guess like the first thing I need to do today is color map, because I'm not even sure this color map is like actually working. Yeah, I think yeah, like the overall idea though, I think is yeah, we want to implement like a kind of like an interaction where the human user can kind of like, I guess, program their own MLP. The idea would be, okay, I can kind of pan by, like, I think if you do, oh wow, that was cool. Yeah, this is not a very good, but anyway, I think what we're visualizing is, each of these matrices is a layer, and it's showing the Hamming distance, showing the difference in Hamming distance between like the input representation and then the layer representation, because each layer has the interpretation of mapping every input point to a new representation. And yeah, so let's just show the raw distances. Right, so these are like raw Hamming distances. Yeah, so like this should, I'm not even sure if that's correct. Let's go to like a lower dimension. Yeah, I think my, is this right? Yeah, I guess that's right. So this is like, so like this row is all zeros, 0, 0, 0. And, you know, the color map is not very good. But anyway, it's, you know, so like it has 0 distance to itself. And then, you know, these are, this is 0, 0, 1, 0, 1, 0, 1, 0, 0. So those are that color. These are distance 2, that's distance 3. And, yeah. So then, dang man. Right. So we have a 20 layer, you know, 3 input, neural net. And, it's kind of like a, you know, cellular automata. This one, oh, my throat just went. Yeah, okay, my, yeah, alright, my throat's back. Right, so, you know, if you just kind of like run these, I think, I mean, basically what eventually happens is, like this end layer, you know, like it you know, like it doesn't change. I think that's because all of the inputs are being mapped to like one of 2 points. Like I think we can check that, maybe. Let's just see what's happening here. Go away. Yeah, oh, yeah. So, right. So, I mean, like, these are the, starting raw activations, which are just the binary strings in lexical order. And, they map through the layers, and then they end up, I guess, being mapped to a point and its negation. Like, is that always the case? That seems to be always the case. It's not really clear. Like, if you have... Right. Right, yeah, okay, yeah. Yeah, like, we're using, like, a threshold Hamming distance, like every unit is computing, yeah, threshold and Hamming distance. Without bias. So I think when you don't have a bias, that implies that if you negate the input, it has to negate the output. Yeah, I don't... Anyways, so this seems to be the end behavior of our model. Like, it maps all of the points onto 2 points, and then it just... So I'm trying to figure out, I don't understand. Like, for instance, I guess it can't collapse. It seems... Yeah, okay, yeah, so, like, it won't be able to compute constant functions, I think, because we don't have a bias. So it can only ever collapse all of the inputs onto 2 points max, I guess. So I guess that's what it does. And yeah, so it seems to... There's also kind of like... Right. Anyway, yeah, so like it maps everything onto 2 points. And yeah, so I don't know. I was gonna say, like, it seems to take, like, I don't know, 10 layers, sometimes more, sometimes less. Yeah. By the way, the thing we wanted to do was, yeah, kind of this, because if you take, wow, this one's weird actually. It maps everything to 2 inputs in a single layer. Yeah, I can see that. And then and then it kind of, alternates. Oh no, it does. Wait. Oh, like it maps them to different... Okay, so it's taking these 2 inputs, or these 2 points, and... Yeah, it's like bouncing them around randomly. And, but that doesn't show up in our Hamming distance. Right. So we're still moving the representation around. But it's maintaining the same Hamming distance. Right. So yeah. Right. So anyway, we have this idea of like a human could program this, because the idea would be like, this is your starting. I mean, a human. Well, I mean, like a human can like select layers. Maybe it's kind of the idea. So the idea would be like that. You know, this is your starting state. It's your pairwise distances between all the inputs, and like this would be like a target state. Because like, I mean, certainly this corresponds to I mean, what this is saying is that, like, you know, these, like, the blue rows are linearly separable from the pink rows. So the idea would be that if we look at, right, so the idea would be like if you look at this entry, right, this is the Hamming distance between 0, 0, 0 and 0, 0, 1. And, so we're saying, like, well, we want it to be blue, and it's currently pink. Like, I'm also going to have to work on the color map, because the whole color map is garbage. But, yes, but you could have this thing, like, where you're here, and then, like, I don't know, maybe you have a tree, or it's just like you're, you could like randomly generate layers, and yeah, like it would just highlight, I guess, yeah, I mean, it'd be kind of hard to do, but like if this were your target, so you're saying like, okay, I want this entry to be blue, right? I want all of these entries to be blue. So any like layer that makes this entry go down, like, is good, at least on that entry. So yeah, I guess it'd basically be like, I mean, you could automate it actually. I mean, you obviously don't have to do a human, but you can imagine a thing where it kind of like, where you're choosing what the next layer should be, and it, so yeah, I guess like for each entry, it would just say like, we're making an improvement on this entry, or like, we're not making an improvement on this entry. And like the only rule is you can't have zero Hamming distance between 2 points, 2 input points that are opposite outputs. Yeah, so you'd basically just be scanning through like next layers. Yeah, and I guess it would just highlight the cells. It'd be like green if it's moving 2 points closer together that are supposed to be classified as the same output. And and then like a red if you have like a fatal, if you have 2 inputs that are being mapped together even though they're supposed to be separated. Yeah. Right? So, Yeah, so I think I'm going to, like, work on the color map first. First, let's go back to, okay, let's go to, like, a higher dimension. 4 dimensions. Is this, so, like, these light ones are distance 1. Right, there's 4 of those. That checks out. Then these are like... Right, the next one would be distance 2, which would be 4 choose 2, which would be 6. There are 6 of those. Yeah, so I think it works. It's just... yeah, like the color pattern is weird. These are... yeah, these are like random parameters. This one seems to... this one does map everything to the same output. I thought that wasn't possible. Yeah. That maps everything to the same output. Right, and it's still bouncing around though, like it's not keeping one output. It's moving around, which makes sense, I guess. Yeah. Yeah, so like blue is having distance 0. And yeah, so like we're just, so you can say, so like the first layer is saying, you know, I'm going to map these two. This is all zeros, and this is 0, 0, 1, 0. I'm going to map those two to the same representation. I mean, we can look at that, maybe. Let's go to the second layer. So this is, you know, right. So it's, right. So I mean, like the first unit maps all zeros to 0, 0, 1, 0. And then like it maps this guy to these two. And there's also supposed to be like a symmetry here. So I don't know how to, what the symmetry is supposed to be. I mean, it's like symmetric over the diagonal because, like, you know, distance ij is the same as ji. But it's, but I mean, there's also, like, I mean, like, if you're saying like this row is equal to these 3 columns and itself, but it's equal to these 3 columns, that means that these 3 columns have to be equal to each other. I don't know how to parse that out on the graphics, but that's fine. Alright, anyway, let's look at like a different 4-dimensional thingy. Okay. This is weird behavior. Like, why does it not map everything? Okay, now we're getting to like, we're also getting different distances. This is weird stuff. This wasn't happening before. Okay, so we're not necessarily mapping units two, their negations, or like the 2 points don't have to be negations of each other. Right. Anyway, like certainly the general tendency of the random neural nets is to map all the points to kind of like the same. I guess that's just because, like that's irreversible. Whereas, yeah. Anyway, yeah. Okay, so anyway, I think I was going to do, I think I'll do an easy thing where we're gonna, under each of these, because like these are the raw Hemming distances, and yeah, what we will do, I think, is subtract this from like every one of these. Yeah, so that should show like for a layer, for every pair, it'll show like how much closer or distant it is relative to where it started. That should be easy. We should be able to bang that out. No problem. That might be it for the day. Like I don't. Yeah. Okay, so like these are the activations, and yeah, literally all we have to do is do this twice. Right. Yeah. This should be easy. So I can either just copy paste this code and then, yeah, I'm gonna do that. I was like, you could make a function, but then it's like you have to like name the function and all of that. That's not what we're here for. Oh, it doesn't like it if you use const twice. Fair enough. Okay, I guess I'll do a function. It got me. Gotta do a function. Alright. Gotta do a little function. Oh yeah, and then we have to fix this. This is the thingy. I gotta make the font bigger. Because I'm geriatric and stuff. Okay. Does that do anything, kind of? Alright, okay. We're gonna abstract, or, I know we're not gonna abstract, we're just gonna make a function. And we're just gonna have 2 rows, right? Like, it's gonna have this row, which is raw Hemming distance. And I'm just gonna have a row below, which is delta Hemming distance. Also, like, delta to the starting. You could also do delta to the previous layer. Will that help anything? Don't know. Okay, so yeah, I mean, the other thing you could do is just say let instead of const. Then we'll have a function. That'll be cool. That'll be really cool. Raw row. And it needs to have I guess like the matrices, and then like X and Y position. X pos, Y pos. Not to confuse it with other possible X's and Y's. And then, yeah, I mean, we'll have to do that twice, but this is all the row stuff for the drawing. So, yeah. Well, that's real cool. Draw row. And, oh no, that's inside of an activation. Yeah, that's fine. So this is just a single matrix. And, right, let's just call the Hamming matrix. Okay. This will probably irrevocably break the thing, but that's fine. Yeah, this isn't actually drawing a row, it's drawing an individual matrix. That's fine. Okay, Hamming matrix, and then it's going to be at the, yeah, this is X position, which is found through trial and error. That should be negative 19. And 0. Okay, so like it should work. Nice. Nicely done. It probably doesn't have access to the scene. I knew this was like a terrible idea. This is literally the worst idea. Layer is not defined. Oh, right. Yeah. That's fine. We can fix that. You just have to, yeah, okay. Alright, so that, you just have to pass it in there. So, plus layer times 2. And then just say response. Yeah. Okay, so we're back to where we were. Good. And then we want to draw another layer, even though, yeah, or another row. Which is literally this. Except, Wow, it's still, okay, these have to be let, okay, go away, I think I need, do you have to like reinitialize this? Don't know. And yeah, it needs to be like lower. Nice. Oh wait, that made it higher. Did that make it higher? Okay. Alright, it's just that easy. It's just that easy. Is this working correct? Oh yeah, that's cool. So, like this is saying, because this neural net is mapping everything to one point, and then like this is just the Hamming, because all these are 0, so this is just the negative of this, right? That makes sense, kind of. Yeah, okay, so like, did that help us in any way? No, I don't really say that helped us in any way. Yeah. I mean, the other problem is the color map. I don't actually know what the color map is doing. It was programmed by AI, so let's yeah, I mean, it's like we wanted 2 different color maps. Yeah, okay, so I mean, the idea for what we're trying to do would be like, you take this as like your target function, because like basically what this is doing, is like it's separating the blue rows from the pink rows, right? So that could be like a target function that you're trying to implement. And yeah, I should implement mouse panning, because all I have is scroll. But Right. So anyway, I guess it's like if you look at the delta between your target function and the inputs, I think this is like where the color mapping is killing me, but yeah, I think also what we need is we need a row where it's like we need the deltas with respect to the previous layer, because these are, this is just saying like this pair is red, which is supposed to mean that it's more distant than it was when it started. And it was supposed to be like the blues mean that the points are closer than when they started. But yeah, the color map is not working. Okay, let's look at the old color map. The thing is like the different rows have different color maps. That's why it's highly annoying. Oh yeah, why do I have a 4 here? Like, there shouldn't be a 4 there. What if I don't have a 4 there? What does that do? It makes everything blue. Very cool. Blue. So, this is saying that, you know, the end, so blue means, so I think blue means 0. So this is saying that, you know, like the input layer, if you subtract it from itself, you get 0. So it's saying, you know, like it matches itself. So then like further down, yeah, I guess I can, because this maps everything to one point. Although I think it's like it's different points maybe moving around. But yeah, it just reproduces the like let's go to a lower dimension, you know. That was way too many dimensions. Okay, where's my thingy? Yeah. 3 dimensions. That's way better. Okay, you know what? Let me fix the color map though, because I don't know what the color map's really doing. Okay, we have this thing, and so I mean, like for the top row, you know, you can have distance from 0 to 3, inclusive, and it's kind of like you want this to be. I mean, that's the problem. Like down here, the deltas can be negative. I mean, they can be like if you flip a point to its negation, that's, you know, you would go from distance of 0. Right, so down here it ranges from like -3 to +3, and here it just ranges from 0 to 3. Yeah, so we need 2 different color maps. Having said that, I will just add a flag diverging ? I don't think you can actually have a question mark. So then, let's just say if diverging, we should say if not diverging, that's the more natural case, isn't it? Else right, so if you're not diverging, yeah, we don't want any of that. So it's just all going to be red, shades of red. And I don't even know what that does. So it's the distance just divided by 6. I mean, just divided by n. Right? That makes sense. Yeah. Right? That makes sense. And then, okay, so then let me go to here. This is false. It's not diverging. And here it's... Wait, where's the other thing? Oh, we need to pass that as a thing. Okay. Divergent. Divergent. And then where are we even calling that? Sorry, where are we calling that? Draw row. Okay. So the raw hemidistances are not diverging. So that's false. And then the other ones are diverging. True. This is terrible. Okay, so if you are diverging, half n is n over 2. And no. If you are diverging, it's 0. And so yeah, then you take the absolute value, and then it's just n. This is n. Okay. RGB, right? I want that to be the other way. I think I just want these to be 0. That's weird. That's not what I expected would happen, but because like I don't understand colors. But that looks pretty cool, so whatever. So yeah, it's like this is raw hemidistance. Sorry, what dimension are we in? 3. Yeah. It's raw hemidistance. This is difference with respect to this. So, right. Right. So you see like a lot of dark blue, which means like it's not, this particular neural net is not really moving stuff very much, I guess. Right. Okay. Very cool. Right. Yeah, let's go back to a higher. Let's go to 5. Ooh. That might break my computer. Oh, dang, man. Is that even working correctly? Well, anyway, I mean, like, you know, here's an observation. You know, like the first couple layers, they're all very blue. Well, it's not really. It should be more. Yeah, why isn't that blue? That's incorrect. It should be 0. It should be white. Yeah, we're still messed up on the color map. Okay. Let me look at it one more time. If I can find it. Okay, we are diverging. So like if the distance is 0, like right here, we want that to be white. Which is, yeah, it should be like this one. Oh, red. Right. So I think we want to have this. Is that cool? No? Oh yeah, now it's cool. Now it's cool. Now it's cool, kind of. Right. Yeah. Right. 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 So here's a conjecture. This white X has to always be there because this diagonal, you know, is saying that the Hamming distance between a point and itself is always 0, so it has to be white. The other diagonal line is saying Hamming distance. Ooh. I mean, that's a point and its negation. I don't know. That might not always have to be white. I don't know. Right. That's cool. I am getting that white. I don't know if that has to be. I don't feel that that always has to be true. Dang. Also, let me do one more thing, because I don't actually know what this is. This was written by, like, GPT. Did that do anything? What did that do? doesn't seem to do anything. Yeah, I'll fill rectangle. Oh, I see. Yeah, I don't think that matters. Right. Okay, what if we also do, instead of this one, it's the per layer interval thingy. So we say, height distance at, ooh, yeah. You're gonna have to say like, activations layer, make layer, that's not right. Activations. This one, J. Is that cool? That is not cool. It does not like that. Why not? Why not? Why not? Why not? Okay, I guess if layer is greater than 0. Right. That's kind of cool. So like any individual layer doesn't do very much. Yeah. Right. So anyway, I think next time we're going to implement the idea of like having a target function that you're actually trying to implement, and then there'll be some sort of interaction where like it probably just randomly proposes layers, and then it shows for each pair, like, it's green if they're being moved closer together and they're supposed to be, or if they're being moved farther apart and they're supposed to be moved farther apart, and then it's red and, you know, the converse. And yeah, then that'll be like a really cool app. Why is there a circle there? Anybody? Like, what the heck? We'll do one more thing here. This is, do like, I need more dimensions. I mean, like, what's the max number of dimensions we can do? I don't know. Let's do 7. Ah, dang, I think I broke it. Ooh. Yeah, I broke it. It's gonna pull through? I don't think it's gonna pull through. It broke it. Seriously? Alright. Oh. Ooh, that's a roughie. Oh, dang, it did it! Whoa! Whoa! Yeah, I mean, that doesn't... It's like the same. Can I zoom? Oh man, I can zoom. That's amazing. Right. Yeah.